Okay, so this is the remainder of the extra practice problem on page 624. I am going to start at number 5 because my family came home and I wasn't thinking correctly. So we're going to find the molarity of the solution with 100.4 grams of magnesium so we need to find moles here. Magnesium nitrate. So take your grams of magnesium nitrate to find your moles of magnesium nitrate. These all cancel out. Magnesium nitrate. Okay. I've done this a few times already, so hopefully I just remember. 16 times 3 plus 14.01 times 2 plus 24.31. 148.33. 16 times 3. I always do this twice because you guys aren't here to double check it with me. Times 2 plus 24.31. Okay, that's what we got. So 100 divided by that number, and you're going to get 0.6741. So sig figs, which is 4, 0.674. That's probably what I'm going to go with. Mole magnesium over, and this is kilograms of water, and you just move that decimal over and you should get molarity of that. So 1.3483. I gotta get back to my answer here. That what they got. Let's see. Number 5. 1.34, yeah. 834, and that's 1.34. I think I would have done 1.348, but they did 1.35. So, and I would have done it because all of them are in 4 sig figs. But there you have that. So there's number 5. Number 6. How many grams of calcium chloride would you have to add to water at 1,250 grams? And we want a concentrate of 2.0 molality. Okay, so if we know that 2.0 molality is over 1 kilogram of H2O, and this is moles per kilogram, but we have 1.250 kilograms H2O. I think they just will multiply this kilograms H2O to get that out. multiply this side, 1.25 kilograms. H2O, of course, the kilograms will cancel out, and that should leave molality. So this is mole. So let's just see how that looks. Two point five molality. And we want to know, right, how many grams. I think that's moles that we need. So we're just going to take 2.5 mole of CaCl2. Here's 1 mole CaCl2 equals chloride 35.45. And 40.08. Oh, wait, try that again. It's kind of late. So I'm having to do a few things over. So I have 110.98 grams calcium chloride per mole. Doing it a second time. Make sure I got it right. Yep, that's the same. And we want to multiply that by 2.5 to get 277.45. And that would be grams of calcium chloride because moles will cancel out. And what did they get? 2.80. Probably accounting for we use more exact figures than they did, but they have 1, 2, 3, 6, 6, and then he have 1, 2. So 1, 2, so that's probably 280. That's where they got it. 280 grams calcium chloride, and that's what they have. Good deal. Oh, I gotta show that. Okay, so if you want to protect from freezing, which compound would you accomplish this best? Well, we want to remember our delta change. So this is ions, negative ions. So this is for freezing. They do have different values, constants. Times molality, temperature, no negative in front. 0.51, that's a 0.512 degrees Celsius molality. Okay, so that's something, those are actually found at the top of the page. They give those to you. So when you look at those, you got to look at Ca3, PO4, 2. There's 3 and 2, so this is going to be 5. Aluminum trait. So there's 1 and 3. So this is 4. And NaCl, which is 2. 1 and 1. So which one would be protect against more? Of course, this one would. Because it has more ions. Okay, then we have 2 more to go. Because of that equation right there, that multiplies by the ions. Three more, I guess. What is the freezing point of a solution that is made by dissolving 20 grams of KF? KF 20 and water 100 grams. Okay, so what is the freezing point? We got to put that in there. So, of course, ions, delta change, ions is going to be negative 2 times 1.86. Whoops. And we need degrees Celsius per molality. Now we need to find molality. So we have KF, we have 20.0 grams of KF. Put that over 1. We're going to find our grams of KF per 1 mole of KF. Potassium fluoride. So it's 19 plus 39.1. So I would say 58.1. So 20 divided by 58.1. I have 0.344 mole of KF. Oops, KF. Now we have to put that over grams. So 0.344. 123 divide that by, looks like a 0.123 kilogram. Whoops, kilogram of water. 30.1. Oops. Equals 3.442 molality. And so if we put that, I think we'll just use these 3.44. We put that in our up here into our handy dandy equation. We're going to take 2 times our answer times 1.86, which I should have, or at least worked backwards at the very least. I have a negative 12.805. 3. I think it's a negative 12.8 delta change. So if we're, that's what I'm showing to you. That obviously you subtract that from 0 to get the freezing point. And that's what they have. Degrees Celsius, of course. Okay, 2 more. Okay, so if you want to lower a freezing point by 10 degrees Celsius by adding calcium chloride, what would the solution molarity need to be? Oh, I don't know why I did that. So we want to keep the freezing point. Delta change of the freezing point, which is a negative I. Negative I for ions. And the freezing point constant is 1.86 degrees molality. I'm going to put my RM here. So my dog is driving me bonkers. He is up here. There, she is up there, making lots of noise. So we know the delta change is 10 and it's freezing point, so it's going to be a negative I. And we also need to know that CaCl2 will give a negative 3. this is our equation. We just have to basically divide by this number here to basically get this all moved out, and divide by this number here to get what our m equals. So we will have 10 divided by negative 3. Why don't we take negative 3 times 1.86 first? And 10 divided by that answer. And I am showing negative 1.79210. So this must be a negative 2. I think that's going to be a negative 10. Because we're lowering it by 10 degrees. So I'm going to say that 1.921 molality, and there are, it looks like, so 10 is actually 10.00. So this is negative 10.00. There are 4 sig figs, so 1, 2, 3, 4. So I'm going to say that molality is 1.792, because I don't see, unless they're going to be going with that one, which I bet so. We'll say 19 molality. Not quite with these. Yep, that's right. So, last one. Okay, what is the boiling point of a solution made by mixing? So first thing, delta change equals the boiling point. So I, no negative, 0.512. That's different than the last one. Oops, and M stays on the outside here. Okay, so we have ammonium sulfide, NH4 sulfide. NH4 is 1 positive, sulfide is in that second column, so it's actually a negative 2, so you need 2 of those. Don't forget that. So that'll make, and let's see here, let's put all of our stuff. We have 50.0 grams, and we're going in water, which is 375.0 grams. So if we have 50, oops, that's not a 5 at all, grams of NH4, 2S over 1, we need grams of NH4, 2, S over 1 mole, NH4, 2, that's a 4 times 2, S. That should give us moles of NH4, 2S. So let's find out what that is. So 1.01 times 4 plus 14.01 times 2 plus 32.06. And I get 68.16. I'm going to do that again, because you guys aren't here to double check that with me. Times 4, it's 14.01. We'll multiply that by 2. Add 32.06. Yep, 68.16. So I'm going to divide that 50 by that number, and that'll give us the number of moles, which is 0.73356. We're going to say 0.733 moles of NH4, 2S. So Now we just plug that into our equation. And so there's 3, 0.512 degrees Celsius molality, which is 0.733, and that's not moles. Oh, nope, we got it. We is moles, but we need to go a step farther because now we need to take this 0.733 moles, divide that by 0.375, because all you have to do is move that over, 0.375, and so molality is 1.95618 molality. Stick with the 3 sig figs, is 1.96 molality. And now we're going to multiply that by our numbers here. And then I see a delta change of 3.01056, which means a delta change of 3. And since we're working with boiling point, we're going to add that to 100, so that'll be 103 degrees Celsius. And let's see. Yeah, because they're at 3 sig figs. So that's the boiling point of that solution of water. Yep, there you go. So hopefully you can see all those. There we go. Not all at the same time, obviously. Well, it's the best we can do here. And just walking through those problems can help you figure that out. We did most of those practice problems, but let me know and we will walk through any more that you need to.